So today, what I want to do is begin Unit 2. This will be in your ebook or PowerPoints. We're beginning Chapter 3. So this is going to be 3.1, Basic Concepts to Probability and Counting. So the big topic we'll be seeing throughout the semester is going to be the word probability. That's going to be the big one. So probability is basically the chance of something happening or the chance of something won't happen. Uh, Again, there aren't any guarantees, but you can kind of make decisions based on this probability. For us, I like it expressed more as a percent, but a probability can also be expressed as a fraction or a decimal. So one of the things that I came across, last summer, mainly, and well, for the last several years, is this COVID thing. You probably have heard of it as well. Last July, I took a COVID test, and it was an at-home test. And, there was supposed to be an 8% chance that when I do this, that it would be accurate. So it's expected to detect the virus 80% of the time. But I took a home test, and I felt pretty bad, and it tested negative. My wife felt quite good, and she actually tested positive. So again, we went on and did this again, and again, I tested negative again on the second one, and she again tested positive on the second one. So needless to say, we still, based on my symptoms, felt like I probably did have COVID, even though there's an 8% chance, the test is accurate. It actually failed. So keep that in mind. 80% does not mean it actually can happen. You still got to trust other symptoms and things like that as we move forward. So that's where I've kind of seen some of the probability is in a lot of data, and mainly talk about COVID. So as we move into this section here, probability, these are some things that we're going to learn in 3.1. We're going to learn how to identify the sample space of a probability experiment and how to identify what we call the simple events. We're going to use how to use the fundamental principle to find the number of ways two or more events can occur. We want to determine how to distinguish between classical probability, empirical probability, subjective probability. And we're going to talk about how to find the probability of a complement of an event, and also how to use a tree diagram and the fundamental counting principle to find probabilities. So we're actually going to get into actually doing some applications as we move through this. Of course, the thing about statistics, about everything's an application. So the first thing we get into is example 1. We're going to talk about identifying the sample space of a probability experiment. So this is the first word we come across, is the probability experiment. So the definition of a probability experiment is this. A probability experiment is an action or trial through which specific results, in other words, counts, measurements, or responses are obtained. So there's some type of counting or measuring. You're gathering data, if you will, or you're collecting surveys, and you're going to create some information from there. So that's going to be what we call the experiment, is we're doing something. So the result of a single trial in a probability experiment is called an outcome. So an outcome is a single trial in a probability experiment. The set of all possible outcomes of a probability experiment is a sample space. Notice how we use this word set of all possible outcomes. When we see that notation in algebra and also statistics, you're going to start to see these little braces. So the set of is actually going to be listing the actual samples. That's going to be called a sample space. And then we have an event. An event is a subset of a sample space. It may consist of one or more outcomes. So these are some vocabulary that we'll start to try to unpack. So up here in our example, a survey consists of asking people for blood types. So notice how the data was gathered by asking people their blood types. So we have O, A, B, and AB, including whether they are HR positive or RH negative. So RH positive or RH negative. My blood type, I finally figured that out. I can actually remember now. My blood type is A positive. So you may have O negative or O positive or A positive or A negative or B positive, B negative, or you could be AB positive, AB negative. It'd be interesting to know your blood type. If you have the type O blood, that actually is very valuable because type O blood is compatible with all blood types. So remember, if I have type, since I have A, my blood type is A plus, the only blood that I can actually get if I needed a blood transfusion or if I needed blood, I would need A plus blood to not have any bad reactions. So again, our question is determine the number of outcomes and identify the sample space. So they want us to determine the actual number of outcomes and then identify the sample space. So there's two things, is how many outcomes were present and what were the actual outcomes, in other words, the sample space. So how we do this is, so we have these 4 blood types, O, A, B, and AB for each person. And they're either Rh positive or Rh negative. What we can do is use what's called a tree diagram. And this gives us a visual display of the outcomes of a probability event by using branches that originate from a starting point. It can be used to find a number of possible outcomes in a sample space, as well as individual outcomes. So there's a couple ways to do a tree diagram. I'm going to go across the page here. So I'm going to have we're going to have O to start with. Doesn't really matter there. So we're going to have type O, type A, type B, and type AB. Those are our blood types. And then for O, you could have O positive or you could have O negative. For A, you could have A positive or A negative. For B, you could have B positive or B negative. For AB, you could have AB positive or AB negative. So if you follow this tree branch, notice how there's an O positive or an O negative, A positive or an A negative, B positive, B negative. So if you look at these final branches here, that actually helps us identify the different outcomes. So since we have these branches here, 1, 2, 3, 4, 5, 6, 7, 8 branches, that's going to be 8 different outcomes. So remember, outcomes was a number. And then we have to find the actual sample space. So the sample space is going to be the actual outcomes. What were they? And that's where you got to put the whole branch together. So O positive. So we use the set notation, set of O positive, and we have O negative, and we have A positive, and we have A negative, A positive, A negative, and we have B positive, and we have B negative, and we have AB positive, and we have AB negative. And that would be our sample space. And notice that there are actually 8 outcomes in our sample space. 1, 2, 3, 4, 5, 6, 7, 8 outcomes. So that's one of the things we're going to be doing is we're going to have to identify the number of outcomes. And sometimes we'll have to identify the sample space. But the catch with the sample space is sometimes it gets so big, it's literally impossible to list it here in this type of situation. So let's try this for ourselves here. For each experiment, determine the number of outcomes and identify the sample space. So we have 3 different experiments now. So a probability experiment consists of recording a response to the survey statement, and that's at the left, and also the gender of the respondent. So we have this survey to the left. Does your favorite team's win or loss affect your mood? So we're talking about sports. So, I know a lot of my friends are UK fans, and when they lose, they are super upset. And I see a lot of postings, and it does affect their mood. And winning also, I see a lot, especially in big games. If they win in a big game, that's huge. I'm a big football fan, and I follow the Green Bay Packers, and they win, I get excited, and when they lose, I get sad. So for me as a male, I feel like my mood is affected by sports. Now, a female, I don't know. I don't know that many females. My wife, she would care less about sports, so it probably doesn't affect her mood. So, so that's what the survey is. Does your favorite teams win or loss affect your mood? And for me personally, I would be saying yes. My wife would be saying no. And there's also this category of not sure. So what we do here in this question one is I can make a tree diagram to kind of see what's going on here. So in the experiment, we have to first recognize that the first thing you have to do is do yes, no, or not sure. So I'm going to use Y, N, and S for those. Now, as far as who's involved in the experiment, it's genders. So that's male and female. So as far as that goes, I can make a branch out and say, well, it could be a yes male, or it could be a yes female, or it could be a no male, or I'm sure, let's keep it consistent there. It could be a no male and a no female, or it could be a not sure male and it could be a not sure female. So what I can do is list a tree diagram to kind of lay that out. So for question one, we kind of see there, as far as the branches go, there's 1, 2, 3, 4, 5, 6 branches. That means there's going to be 6 outcomes. As far as the sample space goes, we'll use the setup, and we would have yes, M, yes, F for female. We would have no M, that means no male, and that would be no female. And we would have not sure male, and we would have not sure female. And that should be the actual 6 actual outcomes. And that's called the sample space. So this would be our SP, or sample space. So if I look at question 2, see if I have enough room to do all this here. I got a little bit of room. Yeah. See if I can do a question 2 here. So question 2, again, it's a good idea to maybe pause the video and see if you can do question 2 on your own and see what you got going on here. So a probability experiment consists of a recording, a response to the survey at the left again, but this time we're doing it by age. We have these 18 to 34s, 35 to 40, and then this 50 and older of respondents. So again, we're still talking sports. Who's mostly affected by sports? Does age matter there? I don't think age matters as much as gender, so I wouldn't see a whole lot of change here, but that's just my gut feeling about that. But anyway, so this 18 to 34, this 35 to 49, this 50 and older, I really don't want to use those, so I'm going to use like labels. I'm going to call 1834A, 35 to 49B, and 50 and older, I'm going to call that C, and that could be then used as my sample space notations. So I have, again, yes, no, and not sure is what the survey has on it. And then my respondents can fall into different categories. So my yeses could be 18 to 34s, or I could have 35 to 49, or I could have a 50 and older. So notice how that would be the yeses. Notice how there would be 3 branches to each one of these. So I'd have, no 18 to 34, no 35 to 49, no 50 to and older. This is where it gets tricky with branches, is they all of a sudden they'll start to get tight together. So I'd have not sure 18 to 34, not sure 35 to 49, and not sure 50 and older. So again, If I look at my branches, that's going to be my number of outcomes. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's going to be 9 branches or 9 outcomes. And then if I want to list my actual outcomes, I'm going to kind of cheat, just use this A, B, and C instead of doing like Y 1834. I'm just going to go like Y A, Y B, Y C, and then I'd have no A, no B, and no C, and then not sure A, not sure B, and not sure. Try that again. Not sure. C. So you should have 9 different outcomes, and this will be my sample space here. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Can't group them by threes. 3 and 3 and 3 is 9. Okay. The last one we have is on the same experiment, but now we're doing it by geographic location: Northeast, South, Midwest, and West. So again, if you want to pause the video and see if you can create a tree diagram, come up with your outcomes and also your sample space. And then just hit play again, and I'll be here, continue on. So here we go. So again, I'm still having this yes, no, and not sure, but I probably want to spread this a little bit far because I kind of see that I'm going to have actually 4 answers here on this bottom part now. So I'm going to have like Northeast, we're going to have South, we're going to have Midwest, and we're going to have West. So I'm going to have 4 branches there. So I'm going to have again Northeast, South, Midwest, and West. And then, so you have this Northeast, South, Midwest, and West. So again, you can kind of see your branches are going to be your outcomes. So 1, 2, 3, there's 4, 4, and 4. That's going to be 12 outcomes. So notice how this gets quite large rather quickly. And that's why we usually don't list sample spaces, because it can take up so much room. So I'm going to have the set of then the yeses would be like Northeast, a yes, South, a yes, Midwest, yes, West. Then I have no Northeast, no South, no Midwest, and no West. Then we would have, this should be not sure actually, NS. So not sure, Northeast, not sure, oops. So it's going to be, there we go. So not sure, South, not sure, Midwest, and not sure, West. So you can kind of see that's going to be your sample space, those 12 items there. Okay, so that gives you a little bit of idea of what outcomes and what sample spaces are. Okay, so we'll pause here and look at the next example here.